In this short demo, we'll see how we can bind values from configuration onto strongly typed objects. This technique can be used to make configuration values more accessible, reduce the noise in your code, and reduce the fragility of using hard-coded strings throughout your codebase. In the next module, we'll be covering a more typical pattern for configuration consumption, but it's worth spending a few minutes on this approach so that we can compare the differences. We'll apply binding within the index page model, where we've already extensively used configuration values. The first thing I'll do here is paste in the code for a simple class to which we'll bind the configuration. I've named this class features, and I've made it a private class within the scope of the index model since it's only used in this location. The binding of configuration allows us to map a section of configuration values onto an instance of an object. In the onGet method, we first need to define an instance of the features class, which we can do using the new keyword. Next, we can call the bind method on the iConfiguration instance. We'll provide two arguments here. The first is the key for the section that we want to bind. In this case, we can provide the home page subsection of the features section using the colon-separated section name. The second argument is an instance of an object to bind to, so we'll pass the reference to our instance of the features class. Once this code runs, any properties on the features class that can be mapped to configuration keys will be set appropriately. We can now refactor the rest of the code in this onGet method to use the values from the features local variable rather than retyping the key each time in order to access the value from configuration. As you can see, this makes the consuming code more concise in each location, since we no longer need to call the getValue method everywhere that we need some configuration values. I'll run the application to check that everything is working as expected. Oddly, the random greeting appears to be missing. I expected to see it here at the top of the page. I'll stop the application so we can fix this bug. Let's remind ourselves of the structure of the features section. It has a homepage subsection and then three configuration entries, the first of which, enable greeting, controls the greeting feature. In the features class to which we're binding the configuration, I named a corresponding property enable random greeting. The property names must match the keys used in configuration in order for the automatic binding to work. This is the cause of the bug in my case. Since there's no configuration value which can be bound to this property, its default value of false is then applied and it's causing the greeting not to be rendered. Let me stress that one more time as it's a critical point. Your property names need to match precisely the key names as they're defined in your configuration. Otherwise, they'll fail to be bound properly. I'll use Visual Studio's refactoring to rename the property and check that my application now works as expected. Perfect. The configuration is now bound and my homepage is rendered as expected and the greeting is displayed. You'll notice that the weather forecast is not present because we previously configured that to be disabled. Let's return to the appsettings.json file and re-enable that feature globally by setting this value to true. At this point, we've covered the basic functionality around defining and consuming configuration from JSON files. The last thing we'll look at in this module is how we can override the configuration for different environments. In this demo, we'll override the configuration when running the application under our development environment. ASP.NET Core configuration supports the ability to provide configuration values which can differ per environment. In a typical example, you may want to configure different database connection strings for each environment where your application will be deployed. When using JSON configuration files, we can provide environmental overrides for the configuration that will apply to those different environments. After our progress so far, the weather forecast is being shown on the homepage of the tennis booking application. It's displayed because the forecast is enabled on the homepage and globally within the application as defined in the configuration. If I expand the Solution Explorer under appsettings.json, we can see that a second JSON file exists. This file is named appsettings.development.json, and this is included by default in the standard ASP.NET Core templates. By convention, when the configuration is loaded, it will look for a file with the current environment name included in it. During development, this file will be loaded after the main appsettings.json file, and the values in the environment-specific file may override any previously configured values. If I open the file, we can see that currently a default override exists for the logging configuration, which applies when we're running the application in development. During development, debug messages will be logged while debugging the application locally. It's unnecessary to include every configuration value in this file, only those we wish to override. For example, we can add a features section with a weather forecasting subsection and override the enable weather forecasting value and set it to false. If I rerun the application, we can see the effect of this change. Now, when the application loads, the weather forecast is no longer displayed because the development environment override took effect. You may be curious how the environment sets when an application starts. By default, ASP.NET Core assumes it's running in a production environment. At startup, it checks for an environment variable that may provide a different environment name. If I open the launchsettings.json file for this project, we can observe that when the project is launched, the ASP.NET Core _environment variable is set with a value of development. This environment variable is applied when debugging from Visual Studio or running with .NET Run. Suppose you have other environments in your organization. As long as you provide a JSON file with a matching environment name in the middle part of the file name, you can specify configuration specifically for use in those environments. For example, if my deployment pipeline had a staging environment, I could add a JSON file to configure it. In Solution Explorer, I'll right-click on my project and expand the Add menu item and select New Item. From the Add New Item dialog, I can filter to the Web File Templates and search for App Settings. I only need to provide part of the prefix in order to locate the App Settings file type. I'll give this a name, ensuring that it matches the expected convention, in this case appsettings.staging.json. After clicking Add, the new JSON file will be added to my solution, and from here I can provide any staging-specific configuration that I need for my application. By default, the file includes an example of providing a default connection string for the staging environment. We don't need to go any further here for this demonstration, so I'll delete this file. In this module, we've learned how the configuration feature works in ASP.NET Core and .NET, and that configuration is stored as key value pairs. We've learned how to define application configuration using the appsettings.json file, and we've seen that the configuration from that file is loaded automatically when using ASP.NET Core templates. We then access the configuration values at runtime by injecting an iConfiguration instance and requesting the configured values for specific keys within the configuration hierarchy. Where we needed to access multiple keys from a section, we saw that we could bind configuration to strongly typed objects using the bind method. Finally, we overrode some values for our development environment. I'm sure you'll agree that what we've learned so far is reasonably straightforward. But Steve, I hear you say, I'm building more substantial, more complex applications than we've seen in the demos so far. What's the best practice for dealing with the configuration in those scenarios? Great news! Stick with me. Up next, we'll take things to the next level and discover a more convenient approach for consuming configuration using the options pattern. You will absolutely want to use this if you're building real-world, well-architected applications.